Okay, in this video, I'm going to show how I designed a Clicky Pen mechanism for 3D printing. It's very useful. You can include this design in a lot of your prints. Basically, it's made up of 1, 2, 3, 4, 5 components. The spring, I pulled it out of actually a soap dispenser. So that's what the spring looks like. Pretty simple. And then the end cap is printed. It's just a part with threads. And then the barrel is probably the most important part because it determines the design for everything. It's not seeing these planes. And then you have the pusher. The pusher and the barrel are actually printed together as one piece. And then the last piece is the cam. And the cam is actually the only piece that's allowed to rotate within the Clicky Pen mechanism. Everything else stays still. So if we take a half section view of this part, looks like this. Oops. Okay. And let's see how the pusher will just basically push against the cam, and it will force the cam to rotate between positions within the barrel. And the spring here is always pushing the cam forward. Probably should have modeled the spring a little bit longer, but you get the idea. So if we hide the pusher, we can see the different positions of the cam. Actually, let's hide that too. And so the cam will either be in this position of the barrel or between the high cam and the low cam. Let's take a look at the barrel by itself. So here, when the cam is between the high cam and the low cam, it'll be stuck up here, and this will be in the retracted position. And then here there's no cam, and there's a spring forcing it. So it'll slide all the way through until it bottoms out against the pusher. So those are the two positions of the cam. Okay, and then let's take a look and see how I designed this. It's basically using the Emboss function. Okay, start in a new assembly. Let's save as. Let's create a new directory for it. Call it reverse 9. And we'll call it Clicky Pen. And now the first part we want to create is the barrel. So we'll say barrel. And we'll start sketching on our XY plane. So the XY plane of the barrel will be the same as the XY plane of the assembly. And just start with an ID and an OD of the barrel. So type in barrel ID equals 18 millimeters and barrel OD equals 24 millimeters. And we'll extrude it for some length. I'm just randomly selecting 18 just so it's long enough. And now I'm going to use the emboss feature emboss feature, you need to have a triangle. And this angle is going to be 60 degrees. And this dimension, it depends on the barrel ID. And, well, it depends on the circumference of the ID. So the circumference of the ID is pi times the ID itself, which we call barrel ID. We're going to divide that by 12. And you'll see why in a minute. And this is going to be the high cam. So let's use the emboss feature, wrap the face, and we're going to call high cam. If you type in the variable name, it'll store it for you, by the way. High cam, and select face here. And there's your high cam. Let's look at it like this so we can see it more clearly. So nothing too special there, it's just the high cam. Now we'll create a low cam that comes directly after that high cam. So create another sketch on the same plane. F7 again. I actually want to see this sketch, so I'm going to share it. And I want to project the point here, because I'm going to touch up on it. So I'll have a constraint there. That'll be vertical. And let's see if it'll emboss this. Emboss. No, wait. I probably need to close that. Now let's see if it'll emboss it before I, yeah, it will. Okay, good. Before I make a big commitment for that sketch, just wanted to make sure that it would emboss it. So let's dimension this. Again, this is going to be 60 degrees with the z-axis. And now this dimension, again, it's going to depend on the circumference, which is pi times the barrel ID. Now instead of dividing by 12, we'll divide by 6. And we're ready to emboss this now. Select that profile, again wrap to face, and we'll call it low cam this time, is equal to high cam divided by 2. And selecting this face. And there is the high cam and there's the low cam. And now let's extrude just this to the bottom of that. That's not what I wanted. To create a sketch first, and now extrude. Select this profile, select 2 to there, and give OK. Okay, after the high cam, low cam, we need another high cam here. Let's hide the sketch since we no longer need it. Unshare, and we don't want to see it anymore. We need another high cam and then a low cam. So the other high cam was this emboss feature followed by this extrusion. And we'll circular pattern. The rotation axis is the Z. And I only need 1. And 1 at, I think should be 60. There's a 2. at 60 and get an OK. Okay, looks like I forgot to select something to extrude, but that's okay, I can extrude it now. Again, we'll extrude it to this face. Okay, perfect. High cam, low cam, high cam, and now we need a no cam. So I'm gonna create a circular pattern of this 3 more times. So one, not that one. This, basically everything. And the rotation axis is this. And I only need 3. And there it is. High cam, low cam, high cam, no cam, repeated 3 times. So that's the barrel. The most important part of the barrel. Okay, we'll go back to the assembly and save. Save. Yes, save. Okay, now we're going to create the pusher. So we'll just call it pusher. And it'll be on the same XY plane that we used to create the barrel. So we'll start sketching again here on the same XY plane. And the pusher obviously has to be less than the ID of the low cam. So we're going to use an equation here. But first we need to link those parameters. Link and select the barrel. And we need the barrel ID. And we'll need the low cam. Sorry, we'll need the high cam. And select OK. So basically it's going to be the barrel ID times the high cam by 2 plus whatever clearance you have. So we can say, I don't know, 1/4 of a millimeter. So that'll be the equation for the pusher OD. So pusher OD equals barrel ID minus 2 times high cam minus, let's say, a clearance of 1/4 millimeter. Let's make it 1/2 millimeter, 1/4 per side. So it's 10.5. Actually, we could probably even make it 1/4 millimeter. Is I think what I did. Actually, let's make it 1/2. It's better. Okay. And now make the pusher ID equals the pusher OD minus 3, 7.5. And then we'll extrude it to that same 18 millimeters that we did last time. Okay, and now we'll do some cuts. The cuts again will be... Okay, next for the pusher, we're going to create the cuts inside the pusher. The cuts inside the pusher are just basically V-slots, but they have to be at an angle. So you can't cut them on the same angle as the cams on the barrel ID, or else you're just gonna push the cams on the cam shaft just up and down without getting it to rotate. You'll see why in a bit, or it'll be clear in a bit. So we'll select the same plane here, the YZ plane with the Z axis, and we're just going to rotate it 7.5 degrees, and then create a sketch on this here, F7, and like I said, it's going to be V's. Oh, I didn't draw a line there, did I? Okay. And it's going to be 45 degrees here. And it's going to be 45 divided by 2. Just select that and hit divided by 2. And let's use a coincident constraint between this and the z-axis. And then dimension this to be pi times the pusher ID this time. And we're going to divide that by 6 so I can get 6 of these. And finish sketch. Okay, and then we're going to use the same emboss feature we used previously, but we're going to cut it. Wrap from face, and the depth, well, it's going to be 3 millimeters, or we can say pusher OD minus pusher ID, and there's the cut. So now we need to create a circular pattern of just that cut using the z-axis and 6 times, and there are the emboss cut features on the pusher. Okay, next we'll design the cam. The cam. Okay, now we're going to create the next part, which is the only part that can rotate in our entire assembly, which is the cammed. And the cammed will basically, once it rotates and it's in this position, it'll be locked here between the high cam and the low cam. And then the pusher will push it back, and then through spring action, it'll slide on this cam, and there will be nothing to hold it, so it'll keep going. And that's exactly why I did these on a 7.5 degree angle, just to make 100% sure that this pusher engages the cam and forces it to slide. Okay, so let's start. Let's create the pusher now. Create a new component. Sorry, cammed. Call it cammed. And let's start on this plane here. And let's start on this plane here, which is basically the face of that barrel. And we'll create an OD of the cam. We'll call it and OD equals, and for now we'll call it 5, but I'll need to link in some parameters from the pusher. Which we need the pusher ID for sure, and we may need some others too, but let's get the pusher ID first. So this is gonna be pusher ID minus Let's call it 0.38. Pusher ID minus 0.38. Why is it not accepting that? Let's see, did I get that parameter in? Link, pattern pusher. Oh, looks like I forgot to select it. Okay, pusher ID, none. Pusher ID minus 0.38 millimeters. And that's your clearance. So that's the OD of the cam. And we'll extrude that. Your default of 10 looks fine. Now we're going to create an emboss feature, but this time it's going to be on the outer diameter of the cam. So we need to create a plane on the outer diameter. So that's an easy thing to do. If we just select this and that. And now that'll be our sketch plane for the emboss feature that goes on the outer diameter here. So the emboss feature, and we want it to engage. So we're going to want the midpoint to be here. Okay, we can project the z-axis, and we can make this on the z-axis, and then we can make this, just choose 22.5 degrees, and then this will be, again we need circumference. So we call that cam OD. Did I have to spell it like that? I spell it. I forgot how I spelled it. Let's see. Cam OD. Okay. Times pi, and divide that by 12, and I need it to be just slightly clearanced, because if I make it exactly divided by 12, it's not going to fit through the pockets. So that's that. Let's see, why is this? Oh, okay, I need to do one more mate here. And this and this, and now I'm ready to do another emboss feature here. So wrap to face, and it's going to create it. Now the length will be, I need the barrel ID. I want it to be between the high cam and the low cam of the barrel ID. So we need the barrel ID now. I need a link, the barrel. I need this, the barrel ID. And the emboss feature will be barrel ID minus the cammed OD. So that's the difference between them. And let's subtract the clearance so it's not going to scratch against the barrel ID. And I forgot to divide the diameter by 2, it looks like. Yes, I forgot to divide. I should divide this by 2. and then subtract the clearance. Like that. Okay, perfect. And now we can see that the cam diameter is smaller than the inner diameter of the barrel, but it's larger than this diameter of the low cam. So when it's going to be in this position, it's going to get locked here. And then when the pusher pushes it and it slides it against this ramp, it's going to slide down and it's going to go into the void, so it'll go into the open position. So next, let's edit that and create 3 of them. Circular pattern of this emboss. The features are selected and we only need 3. Okay. Okay, and that's pretty much it. The rest is just getting from this point to the assembly I showed in the beginning, which looks like this. So I just added a pocket for the spring. I added threads to the barrel so it'll mate with, so I can thread on an end cap. So we can see the end cap looks like this. And then the spring comes in here. And I'm not sure where the spring is. The spring comes in here and it just pushes it. So that's pretty much it. All right. Thank you. Okay, here are the 3 parts that I printed in Cura Slicer, that I 3D printed in Cura Slicer. This is the cap here. So you can see, if you look closely, it's got the threads pointing upward, and this part doesn't need any supports. The cam definitely needs some supports to get you the camshaft, and the ID also here needs to be supported because to hold that spring in, and the barrel and the pusher needs a lot of supports, and this was actually kind of a pain to remove all these supports with the PLA clipping tool, but it's not too bad, but it takes a few hours, and you have to be a little bit careful not to damage your part, because I designed this to be only 3 millimeters, and in retrospect probably would make that a little bit bigger. And even the wall here too is only 3 millimeters from here to there. And next step is just to print the parts. Okay, here are the parts once you print them. Spring, of course, is pulled from a soap dispenser. This is the cam, the only part that rotates, the end cap with threads, and this is the barrel and the pusher, so you can see that it's printed together. So first we'll put the cam inside the pusher like this, fit it in like that, and then we'll put the spring right here, and then we'll put the thread here like this, the end cap, and then we'll see it in action. So I put a little slit in the end of the cam to watch it rotate. So it comes out there. This is a side view, maybe that's clearer. So it's got a stroke of about 6 millimeters. So that's in. And then that's out. And there is your, you can notice that that cam is rotating. So again, we'll make the two sounds that a clicky pen mechanism makes. There's one. That's when it's in. And that's out. And that's your clicky pen mechanism. A 3D printed clicky pen mechanism. That's back in. And that's out. Okay, that's it.